lots of visuals to skim through and to tie some of these themes and concepts in focus. My whole world has always been about integrating the arts and sciences since I was a little kid. So I always saw that confluence, kind of recognizing what is in our bodies naturally. We are kind of an integrated matrix that way, and I always kind of stumble and catch myself every time I hear certain expressions about how absolutely lateralized we are when we say, you know, I'm going to be perfectly objective about something. And when you begin to study the brain, I see all kinds of this complete integration. And I'll talk about that some through the art, I want to say, and I'll try to tie some of these themes and visuals together with these impressions that I've put together for you tonight, just briefly. I don't want to put a specific time to these. I put split second there, but they could be in milliseconds, they could be in nanoseconds. So we're not going to get literal about it per se, but I'll show you some constructions that might interest you in sort of my impressions and work over the last 30 years, just very quickly. That little piece you see there was first shown at the Museum of Modern Art in Paris in 1982 in an exhibition called Alias that was about this integration of art and science and technology. And they had all sorts of people who, as engineers and artists and visualizers, were putting a whole range of new aesthetic experiences and sensibilities together. And in fact, they were doing so like this structure you see, Takis, it's the big sculpture that actually made noise in front of this giant piece you see here that is called thought assemblies. That was my visual representation of my doctoral thesis at MIT. And I'll tell you just something briefly about that, where we had actually, it was the first of its kind. And so we had to have people from architecture, from the Center for Advanced Visual Studies, like Otto Pina, who is core to the Center for Visual Studies. And you had a fellow named Eric Schwartz, who was a neurophysiologist and nuclear physicist from Brain Research Lab at NYU Medical, and Stan Anderson, who was head of the architecture department at MIT. The first thing we all had to do, and Jim Ackerman from Harvard, who was a scholar on Renaissance art and architecture, just to show you, we had just the board alone to officiate over this, because what they wanted was to make sure there was great science behind the study of this particular construction. Was about looking at the nature of the creative process, human creative process, and trying to kind of deconstruct it a moment and begin to understand certain structures, the architectonics of thought, so to speak. And one of the things that I discovered in the course of my passion for studying brain science and other areas in the physical sciences is that we have become so sophisticated and advanced in reaching for greater complexity and understanding and wanting to foster things like creativity, innovation, problem solving, real world problem solving and so forth, that we haven't actually stopped a moment and do the kinds of things that people like the famous biologist at MIT, Jerry Letvin, has often done, which is back way up and ask fundamental questions like, what is a thought? Okay, what is the creative process underlying a thought? And physically, how do you represent the human thought process? We're still trying to understand some of the most basic elements of the creative process. And yet, at the same time, we're trying to race to understand how to foster innovation, collaboration, and all the tools that we know that we need to make the kinds of advancements using STEM that you've heard tonight. Harvey Sifter talking about the advances that are necessary. So that large construction there, by the way, is about 127 feet, 9 feet high, has 515 images or pictures of representations of the human thought process. And that just shows you a little detail of it. And these 11 sections are, again, taking apart a moment of intuition and analytic reasoning. I wanted to understand if we could neurobiologically see the difference between these two different states of mind. So this was back in, started in 1979. So to give you a sense of date, and we were just beginning to learn how to use various tools. The non-invasive medical imaging tools were just kind of coming to be, and so I was trying to use the arts, the visual arts, something I've spent a lifetime using various kinds of tools, and the sciences together to understand the nature of the creative process. And so these constructions that you see, I'll just show you, and this gives you a sense of the organizing principle. Sort of if you look right in the center of that cytoarchitectural map there, I was interested in that section in the center where, in fact, our emotions and feelings are actually integrated with our cognitive, so our affective and cognitive. I was very interested in those dimensions of the creative process that we often don't get to see. So this giant piece, you almost needed roller skates. It was like a 12-story building turned on its side, and it's looking at from 10 to the minus 12th to 10 to the 12th. Very short amount of space and time to look at this whole compilation, sort of a mosaic of visual representations, interpretations of looking at in as much detail as I could on a kind of micro level and macro level information that we're learning about how the brain learns and sees and puts ideas and information together. So that giant piece in the background, just to give you an interesting connection here with STEM, is I had to do a lot of the science engineering behind that new material you see there. It's about 12 feet by 100 feet long. And I had to invent and patent some new technology that involved everything from viscosity studies to new materials and material science to look at and build the giant structure that was like a slice of the human brain. It's called the Brain Theater of Mental Imagery. And to do that work, it was actually inspired by these Golgi stains that I was fascinated by. I was taking a course in human nervous system at MIT, and there was a terrific neuroanatomist, Dr. Leonardo, who showed me various slides that inspired me. And I said, gee, I'd like to actually take that and envision something that was to that scale. So you were kind of engulfed in it and part of that experience. So just to show you the paintings there, it's very layered. There are layers and layers and layers of materials, these synthetic canvases, just to give you a sense of this construction, and looking at different aspects of the human nervous system from different angles and analysis. There's even a white light projected hologram there with a mind icon that's projecting this kind of hostile image right out of this area called it's sort of the midbrain, diencephalon. This image seems to leap out about 3 feet, and it was constructed and built with the help, collaboration of a terrific holographer, Julie Parker, who was also one of the people who was working at the Media Lab and other places at MIT. And so these spontaneous collaborations often happen in the course of trying to figure out how to pose questions and represent information, ideas that in fact are, to use a term from a colleague, very close colleague, friend of mine, Robert Root Bernstein, he refers to transdisciplinary thinking in nature. It's kind of an integrative study. How you use the sum of our knowledge in an integrative way. And so these constructions and visualizations are really in the spirit of trying to get as close as we can in trying to represent something that is all about what I would call abstract realism, sort of the abstract properties and aspects of reality and how reality shows us and illuminates things that are quite tangible in some way, but you have to find a way to construct a visual or some kind of tangible representation of it to allow the mind to kind of work and begin to see possibilities for maybe new ways of applying the kind of creative inquiry that we engage in, both from the science field and the arts in that dimension. But when I make these works of art, when I make these constructions and symbolic models that are metaphorical in nature, they're really put out there in the world as a way to generate questions and to actually set those questions up as we begin to tackle the issues that are so structured and layered on the information that we're given. And I've always been intrigued by looking at more dimensions about the human brain and mind that may not meet the eyes and may not meet our physical senses. And so when I would make these objects and talk about the connections between the human brain and nature, and between those connections of the brain and the things it makes, and that arc that fascinates me.